Hello guys, welcome back to our channel. Today we are going to see what is an encoder, how it works and how to make the Verilog code for this encoder. Encoder is nothing but a device which will receive information and it will be converted into some coded code. This encoder can be used as a conversion for octal to binary or hexadecimal to binary or decimal to binary code. The encoder will consist of 2 power n input lines and n output lines. That means here in this we have 8:3 encoder. That means we will have 8 inputs. Then how many outputs will be there? Here 8 is nothing but 2 power 3. So we will have 3 output lines. Let's see how the truth table and the logic circuit will be. Okay. Now firstly I will draw the truth table circuit. Here we are going to decimal number and we have outputs D0, D1, D2, D3, D4, D5, D6 and the D7. Okay, right? And binary output. Here we will consist of Y2, Y1 and Y0. Okay, what are the possible numbers? We have 0, 1, 2, 3, 4, 5, 6 and 7. These are the 8 numbers we have. Now in this video we will make these 8 numbers coded into the binary number. So for 0, 1 will be there, 0, 0, 0, and next for 1, 0, 1, 0, 0, 0, 0, 0, 0, and next 0, 0, 1, 0, 0, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1. This is the truth table. For 0 we will get the output as 0, 0, 0. For 1 here the output will be there. That means every decimal number we will get certain output, which is nothing but the encoded output. Okay, let's see the logic diagram for this. Here we will have 8 lines, 1, 2, 3, 4, 5, 6, 7, 8. Okay, here how many outputs are there? 3, right? So we will have 3 OR gates. Okay, here what are the inputs are there? Here what are the outputs are there? D0, D1, D2, D3, D4, D5, D6 and D7, right? Here you can see that for Y0 where we get the numbers at the 1 here, here, here and here, right? So what are these numbers? 1, 3, 5, 7, right? So I will make this. Okay, here I am writing this as a y of 0, this is y1 and this is y2. For y0 what we are write? 1, 3, 5 and 7. And for y1 where we have get ones? Here and here and here, right? So what are the numbers? 7, 6 and 2. Okay, here 2, 6 and 7. And for y2 which is nothing but this, 4, 5, 6, 7, right? So I am drawing all the lines and connecting these lines to the OR gate. So in this way the encoder logic diagram will be there for the 8:1 encoder. So let us write the expressions for this. For y0 what are the expressions? D0 or D3 and D5 and D7. These between these bits the OR operation will be done. For y1 what will be there? D2, D6 and D7. And for y2 D4, D5, D6, and D7. These are the logic expressions for designing the encoder. So now let's start making the Verilog code for this encoder. Okay guys, let's start making the Verilog code for the encoder. So for that, I am creating the module with the name called module encoder. What are the inputs? Here we are designing the 8 is to 3 meg encoder. So for that we will have a 8 inputs. So what we have to write 7 is to 0. 0 to 7 there will be 8 inputs, and I am taking the variable as D. And for output we will have 3, right? So 3 is to 0, and I'm punching Y, and I'm closing this module, and I am assigning the each and every operation to the data and the output. So first I am starting with the y0. Y0, what will be there? D, and just copying it. So I will give in the what we have the write the expression for the y of 0, D1, D3, D5, and D7, right? And next for y1, what we have written 2, 6, and 7. And finally, Sn y of 2 is equal to 4, 5, 6, and 7. I'm closing this module. Okay. Now let's make the test bench to verify whether it is working or not. So for that, I am going to create the test bench with the name called module TV. What are the inputs we will represent is with the register, right? Register 7 is to 0, D, and Y 3 is to 0. Sorry, here only two inputs, right? So we have to take 2 is to 0 only. And I think here also we have to change, yes, 2. Okay. Next, we have to write all the inputs and outputs, right? So encoder D comma Y. Now I am going to start giving the test bench. Now in this video we will change where see way of seeing the output. In previous file we generate the graph files, right? In this video we will see the output in the console itself. So for that we have to write the $display command. $display rows. What will be the branches are there here? Y equal to percentage b. Okay, here y equal to percentage b, and d equal to percentage. It is nothing but the representations. And here what will be the there, comma d comma y. Okay, now we will give the inputs. What will be the d is equal to, for 0 what we have, right? 8 bits, right? 8 pz 8p 1 1 2 3 4 5 6 7. Here we have written like this, or we can also write the representation of the binary such as 128. Okay, I'm giving the delay d equal to, I'm just copying this syntax. Okay, next one is the 64, next one is 32, next one is 16, 8, 4, 2, and finally 1. And I am finishing and closing this statement by giving the $finish command, and I using end and an end module I will end this test bench. This is the test bench code required to verify our encoder operation. So I am going to save this file. Before that I am going to Tools and simulators. Tools IQRS 0.9.7. Okay, right. Now I will run this. I will save and I will going to run this file. Yes, the file is running, and we have to give the name, right. So I'm giving the encoder, which is nothing but 8 is to 1, right? 8 is to 3. 8 is to 3. That means 8 inputs are there and 3 outputs will be there. I am going to save this file. Here there is some error is there. Yes, here we have to use dollar monitor. It's verified. Yes, you can see that for 00, for 0 what will be the binary value 1 triple 0 triple 0, right, and the output is there y triple 1, right.